The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon or good day to everyone who's on the webinar right now. My name is Trish Martin and I work with OEKO-TEX here in the United States, and we're excited today to offer an international group presenting you some information about OEKO-TEX's new testing on GMO inorganic cotton. The webinar today, you'll notice that you have been muted, and that's to improve the sound quality of the recording for everyone. You'll also notice on the right-hand side of your screen, you should have a dashboard of sorts, and there is a question function there. If you are interested in submitting a question for the Q&A section at the end of the webinar, please go ahead and type your question in to that question function, and we'll answer it as we can. If we're unable to answer it on the webinar, we will certainly be in contact with you after the webinar to provide the information that you're looking for. We are expecting to have some audio glitches that we've been experiencing over the past few webinars that we've done. If you do notice that the sound on your side goes out, I will come on and let you know that that is a system problem. They usually last about 30 seconds, and we will make sure that Timo picks up where he left off when we lost the sound, so please don't worry about that if that happens. We will also be sending out a link to the recorded webinar for everyone, and you are welcome to use those and share them with your colleagues who are unable to attend the webinar today or who may have interest in the subject matter. We will also be encouraging you to get in contact with the local representatives of OEKO-TEX in the countries where you are residing, and we are happy to help you in any way that we can with questions that you have about this new testing service from OEKO-TEX. We're very excited today to have as our moderator John Mowbray. He's, for over a decade, has been with Eco-Textile News, which has provided unrivaled expert comment and broken thousands of news stories on environmental and social compliance within the textile supply chain around the world. Eco-Textile News is a credible, influential voice with retailers, brands, and NGOs as it aims to guide the buying decisions of key international companies on how they can and should source textiles and clothing within their global supply chains. The magazine was funded back in 2016 by environmental journalist John Mowbray, who is also the founder of MCL News and Media. His one aim for MCL is to provide inspirational content that motivates key textile industry stakeholders to make a positive difference to their global supply chains through innovative, sustainable, and responsible sourcing policies and practices. Back in 2007, John co-founded the UK not-for-profit textile organization, The Right Group, with Marks & Spencer, that has now been merged into the University of Leeds. And since 2009, he has run the Planet Textiles Summit on sustainability in Hong Kong, Shanghai, Copenhagen, and Bangalore. In 2018, Planet Textiles will take place on May 22nd in partnership with the Sustainable Apparel Coalition. An award-winning environmental biology graduate from the University of Manchester, John bears the necessary scars of a semi-professional footballer and is a keen mountain bike rider and an FA-qualified soccer coach. In addition to his day job, John is also trying to master Spanish, build a new house, and also doubles as a taxi driver for his teenage sons. So John, go ahead and take it away.
Thanks very much for that introduction. I didn't realise you were going to read all that.
Absolutely, very interesting.
Thanks very much, and welcome to this OEKO-TEX webinar, everybody. Obviously, I'm John Mowbray from Eco-Textile News, and I think that the fact that Eco-TEX is about to launch a new GMO test method for organic cotton is very significant for our industry. Over the years, we've reported on GMOs and organic cotton, and organisations such as Textile Exchange are convinced there is a rising demand for organic cotton products at retail level, but this demand's usually outstrips supply greatly, causing a gap between the two. But what I've seen over the years as the editor of Eco-Textile News is that one of the reasons that the organic sector has remained static was a loss of confidence from retailers and brands, really due to a perceived lack of transparency within the supply chain. This came about after a number of reasons, but one of the big reasons was the incidence of widespread fraud in India with fake certificates back in 2010, causing some retailers to withdraw support. And in the past, testing for GMOs has been requested, but testing laboratories have often agreed that processed fibres, particularly those subject to heat or chemical processes, have no longer contained enough nucleic material for a reliable test result. Up until now, actually, I understood that once organic cotton fibres have been bleached, dyed and processed, all traces of genetic material from the seeds will be lost. So the fact that OEKO-TEX has developed a new test which presumably can identify nucleic material in garments is quite significant, and I'm sure that our readers and people on this webinar will be interested to hear much more about it. So without further ado, I'll pass over to Dr. Timo Hammer, who will guide us through how OEKO-TEX can give buyers and users of organic cotton more confidence in supply chain traceability, and perhaps, you know, eventually give a boost to the organic cotton sector. So without further ado, it's over to you, Timo.
Thank you so much, John. Thank you, Trish. So welcome everybody also from my side. I'm very happy to give this webinar today on behalf of the OEKO-TEX Association. My name is Timo Hammer. I'm working as a CEO, Life Science and Care at the Hohenstein Group in Bönnigheim, Germany. And I'm a biologist by training, and after that I did some economics studies and started in Hohenstein in 2009, heading the research group there. And since 2015, I left for 2 years and worked for the medical device industry. So I did something completely different, but I got a lot of insights into this kind of industry. And in April 2017, I was very lucky because I was offered the job to become CEO of the Life Science and Care department in Hohenstein again. And throughout the last years, Hohenstein scientists invested a lot of effort in developing and further evolutioning this kind of GMO testing I'm going to talk about throughout the next 25 minutes. I will tell you a little bit more about the background and about the trend, but I think the audience today is very, very deeply into this topic, so I don't have to tell you all the general things. So I will make a brief introduction into the topic, and then I will focus on the test itself and more the technology. So also from my side, if there should be any audio problems, I really apologize. We try to fix it, but you will not lose anything, so I will repeat then if you don't hear it. Okay, so just another point before I start. So I am talking on behalf of OEKO-TEX, presenting the test. However, if you have specific questions with regard to the OEKO-TEX certification process and the, how does it work with the test, how is it included into the OEKO-TEX systems, these questions will be better addressed to my OEKO-TEX colleagues. Whenever it comes to technical questions, questions about the test and genetic engineered cotton in general, you can ask these questions today. Thank you very much, and here we go. So we realize here in Germany, but all over the world, that organic cotton is a mega trend. I don't have to tell you, in the stores, we run over all these kinds of labels, and I put only a few here in this slide, and throughout the stores, they jump into our eyes because the companies are really doing a lot of effort, a lot of advertising for organic cotton. So this is the one mega trend, and the other mega trend is for sure that the end consumer gets more and more kind of curious and wants to know more details about the product he or she is purchasing, and therefore you know that some companies are working with QR codes which you scan and then get all the informational background about this textile you just purchased. And therefore, it's clear and logic that organic cotton needs to be traceable, and best would be to have complete traceability throughout the chain. And I think that was the main challenge in the past. So we focused very much on optimizing this test to be able to do it on processed end products. And that's what I'm going to talk about today. So just to bring everybody to the same level, this is public information. So the growth of GMO cotton worldwide, and I really apologize, the letters are in, so the words are in German, but I will explain the two slides right now. So on the left-hand side, you see the proportion of genetically modified cotton in cotton growth worldwide. So you see that everything started in the late 90s, and there was a strong increase until 2012. And since then, we have kind of stable, like about 70% proportion of genetically modified cotton. So one fact we see is that there is no further increase. We got kind of a stable niveau of GMO cotton growth worldwide. And on the right-hand side, you see that it really differs from country to country. So it all started mainly in the US, with then China coming up, the yellow part, and then strongly developing supply of GMO cotton from India throughout the last, let's say, 10 years. So just, being a biologist, I have to talk about biology, even if it's just for fun. But why? Why has genetically modified cotton been introduced to the market? And what was the idea behind it? So genetically modified cotton the idea was to avoid some problems caused by the cotton bowworm. So most of you might know this little animal feeding on the cotton bows. So insecticide production, so insect resistance, was one approach which should be achieved by genetic modification. So the cotton plants were engineered in a way that they produce an insecticide on their own, and the cotton bowworm dies off when feeding on these plant parts. Another approach is very well known from food production. It's the so-called Roundup Ready approach. So it's herbicide resistance brought into the cotton plants in order to spray the cotton fields with glyphosate and like killing all the herbs around the cotton plants. And the idea behind it is that only the cotton plants survive, and all the water and all the fertilizers can be used exclusively for the cotton growth. And these approaches were very promising. So that explains the steep rise of planting genetically modified cotton in the beginning. And of course, it was the big well-known agricultural companies introducing these cotton plants. I attended the Textile Exchange conference in Washington last October, and there was a very nice talk about the development of GMO cotton growth, and there was reported that more and more herbs are resistant against glyphosate, for example. So that approach has become weaker. And on the other hand, other insects, other animals have rised, which feed on cotton now, and which are like kind of resistant against the insecticide. So there are challenges, there are some problems, and I guess that's why the growth of GMO cotton has kind of reached a stable niveau and is not further growing. But to sum it up, and you all know these numbers, nowadays we have like 70% of global cotton production is GMO cotton, with in some countries, for example, India, being about 97% of GMO. So it's a big proportion. And I told you that the genetic modification makes the cotton plant herbicide or insect resistant. And in not always, but in many cases, organic cotton is more expensive. May it be for the companies, may it be for the end consumers. I know that's not always the case, but many times. So independent from the pricing, the manufacturers and the end consumers, they just demand complete traceability. So we call it from the seed to the shirt, to assure that it was only non-GMO cotton used for the cotton I purchase, or for the fabrics I purchase. And we have the mega trend of a rising demand for organic or bio cotton, non-GMO seed. So it's always in the discussion of organic, bio, and what does that mean, and what do we test, and so on. So I have to make it very clear. So in the mostly used definition, organic cotton means that we don't use pesticides, we don't use synthetic fertilizers, and we use only naturally grown cotton plants. So breeds, yes, but no GMO cotton. And the test I will present you today tests only the parameter of GMO. So with only this test, you could not tell it's organically grown cotton or not. So just to make that very clear, but under the umbrella of the other OEKO-TEX tests in the standard 100, we cover most of the important parameters. So what does that mean now for the OEKO-TEX process and certificate? And once again, I'm not the expert for this process, so if you have any questions on that, please ask my OEKO-TEX colleague. So far, until the end of March, it was a case that companies which declared their standard 100 certified cotton products in the article group description with the specifications bio, biological, organic, they needed to send a valid certificate. Now we have a two-step system which was introduced April 1st. So first step, the producers have to submit a valid certificate to the OEKO-TEX Institute, which identifies the biological origin of the material as it has been before. But now, being able to test on this parameter, the articles must pass through an additional lab test I'm going to present you in the following slides, in addition to the pesticide test, which is already part of the standard 100 testing list. So in the certificate, it was, so not currently, it was until the end of March, sending a certificate. Now, with 1st of April, we need the certificate plus the GMO test. Why? So the current certification system for organic cotton is, as you all know, based on certificates, and in very few cases only there are really lab tests done. I know, and John really nicely introduced the topic by saying that there was a lot of doubt, and there is still a lot of doubt towards testing and complete traceability. And there are a lot of rumors out there. And I try to tell you today that in most cases, we are able to test these products. So far, there has no reliable test been on the market. So current certification relied on certificate chains or sometimes on testing the seeds on GMO content. So the harder the cotton is processed, the harder the DNA test for GMO. That's true. But I can tell you now that what John mentioned before, so that processing like bleaching and so on in general does destroy the DNA and makes us unable to test, is not true. So I will tell you a lot of some results from our validation, and becomes clear that if you optimize the DNA extraction process, we are able to test down to the shirt. So because if you test the seed, there's a long way to the final product, and there are a lot of points here where you could be faced with contamination on the area where you grow the plants, in the mills, and through the spinning process, blending different fibers, and up to the final shirt. So there are a lot of steps where we could have kind of contamination of organic cotton with GMO cotton. So what we did was we optimized sample preparation and DNA extraction to the final product, which means if we are able to test the final product, we are also able to test the intermediates. If in few cases we're not able to get enough DNA from the final product, we can go back step by step and try to get enough DNA out of it. The test result is very easy to understand. It's yes or no. And that's what the test report also looks like. It's yes or no, and easy to understand. Because, and I know there's a big discussion about quantification out there. In my opinion, quantification currently is not reliably possible. So quantification of GMO content, and I will tell you afterwards why this is my opinion. So reliable GMO testing helps you to minimize the risks along the supply chain, which means mixing of conventional and organic seeds. So in the very beginning, contamination from neighboring cultivation areas, contamination from process, and in the end, incomplete traceability of the organic cotton. So let's come to the test procedure. In the first step, the sample, so the fabric, is crushed and the cotton fibers are degraded, on the one hand mechanically, but in addition enzymatically. So what do we want to do? We want to get the genetic material out of the sample, out of the fibers, without destroying it, and then purifying it, which is a multi-stage process. So the DNA, as John already mentioned, is located in the nuclei of the cotton plant, and we find these nuclei in the cotton fiber. So what we need to do, we need to come there, extract DNA without completely destroying it, and then from this very, very tiny amount of DNA we get out of it, we need to do step 2 and look for the specific marker genes which show us the genetic modification. And therefore we use standard molecular biology technology, or real-time PCR technology, and with the respective control reaction I will explain to you afterwards. So what we are doing there actually is amplifying the areas in the DNA we are looking for, and only if they are present. So only if we are able to get them out of the sample, we are able to amplify them and to do the test. So basically, we select the sample and mechanically degrade it. There's enzymatic digestion in multiple steps. We purify the DNA, and we do then step 2, the detection reaction for the GMO. This, as I already said, amplification processes targets only the target sequences we are looking for. And for that, of course, the target sequences must be known. So they are so-called marker genes. How do we know what we are looking for? Well, whenever genetically modified cotton breeds are introduced to the market, they need to get approval, and they need to be published. So we know which cotton lines are out there, and are thus able to detect them. Of course, as with every analytical method in the lab, we have kind of a natural detection limit, and the normal detection limit for the method we use is set with 0.1% of GMO cotton content. So if there is less than 0.1% of GMO cotton of GMO cotton DNA from the whole DNA we extract, we might not detect the genetic modification. So this is kind of what the results look like. So if we get this increase in this rising curve here, this is a positive signal. So there was something to be amplified, and the marker genes could be detected. We have a yes GMO positive sample. If we don't detect GMO target genes in the cotton samples, we have a curve like this. So in addition, of course, we need to ensure that the samples are not contaminated. So we need to run negative controls. We need to work in a very clean molecular lab environment. And in addition, we need to be sure that the extraction and the amplification itself really worked. So we need to do an internal control. Does the PCR reaction really work, or do we have some problems with the machine or so on? In addition, we need to be sure that we really got cotton DNA out of the sample, because this is the critical step, as I already told you. So what we need to do is to run another PCR showing that it's really cotton DNA we extracted from there, and that we have enough DNA to really do this kind of test. And in the end, the sample shows us it's GMO or non-GMO. So let's talk about the limitations. And I will be very honest with you. So in the beginning, when we optimized this test, it was really a challenge to get access to a sufficient amount of DNA out of the samples. And by optimizing the test, we found a way to decrease the percentage of failing tests down to 8 to 10%. So still today, in 8 to 10% of the samples, we are not able to extract DNA. So the control reaction does not work, and therefore the test cannot be performed. In this case, we cannot give a GMO yes or a no result. And as I already told you, the detection limit of the method itself is set with 0.1% of GMO. So what we did in our validation process throughout the last years was not only optimizing the lab test, we draw a lot of samples from the market. So we went to the stores, we bought socks, jeans, shirts, whatever, and tried to do the test. And after having all these results, and we knew, okay, in 90% of the samples it worked quite well, but in 10% of the samples we didn't get enough DNA out of it. We tried to find any kind of a pattern why in these 10% the test did not work. So we checked how these products were processed, and does, for example, color have any impact? Has there been bleaching, alkali treatment, and so on? And what we found was nothing. So there was no pattern. So I'm very happy, John, that you introduced it in that way, that it is said that bleaching and processing and heating and so on completely destroys the DNA. So this is not true. So we were able to test bleached products, alkali treated products. So there was no pattern recognizable of how these fabrics were treated and why the test did not work. So we for sure go on. We want to bring that 8 to 10% down to 0 and try to find out why some samples are not able to be tested. But so far, I can tell you there is no certain pattern. I think that's also important to know. So that's already my last slide. Thank you very much. I hope you got a brief introduction into the new test, and I'm pretty sure that some questions come up in your minds, and even if we are not able to reply to all your questions after that webinar, as Trish already indicated, you will have the opportunity to bring in your questions and they will be sent to the respective expert and be replied as soon as possible. So once again, thank you very much for your interest, and so I'm looking forward to the Q&A session.
Well, wonderful. Then we'll start that right away, Timo. So folks, again, if you look over on the right-hand side of your screen, you should see a question function. And if you have any questions for Dr. Hammer or for John, you're welcome to type those in there and we'll try and get those answered for you. Timo, I do have some questions for you already. So let me dive into those. Is this new test valid for any other cellulosic fibers, or is it just good for cotton?
It's just good for cotton. So what we're targeting at is cotton DNA. And as I already told you, as we need to exactly know what kind of genetic modification has been used to look specifically for that one, we just focus on cotton.
Okay, wonderful. Are there plans to roll this kind of testing out for any other kinds of cellulosic fibers, or is GMO an issue with those fibers at all?
In my opinion, it's not an issue at all, because there are genetically modified cotton plants out there to about 70%, but you know, the viscose fibers coming from other plant sources and so on, or also other biological fibers like wool and so on. I think genetic modification does not play a role in these fibers, so that's why we focus on cotton only.
Wonderful. Okay, so if I am a manufacturer of apparel and I have a line of, let's say, using shirts as your example, and they're available in multiple colors, how is it required that I submit different testing for each color within that line to confirm that they're all organic?
No. So if color is the only difference, it's not necessary to test all colors, because if the cotton contains GMO or not is a question of the raw cotton material. And if you take the same fabric and dye it in 5 different colors, there is no difference in the result GMO or non-GMO. So if the only difference is color, you don't need to test all the colors. However, if, for example, the different colors have also other differences, like other fabric sources or so on, you need to test these.
All right, let's see now. How long does the test take from the time I submit samples to the times I would have results?
So the standard lead time is 10 days. So it's done within the normal timing of all the other standard 100 tests.
Okay, all right. And if I do submit a sample and it does come back that GMO was detected, is it possible to tell which marker was detected in that sample?
Not with that standard test. Detecting the markers in general is possible. So from a molecular biological point of view, it's possible, but it's a lot of more effort. So that would be a question of if it's really worth doing that test. But in general, it's possible, yes. However, we do not offer it as a standard because it makes the test much more expensive.
Understood. Okay, John, actually, this question probably is better answered by you. It's actually about the GMO market. And the question is, what's the reason for the decrease in the use of GMO cotton? And how is that happening when we hear about the lack of controls for limiting the spread of GMO cotton?
Well, it's probably something to do with what Timo was mentioning earlier, to do with a natural plateau that we're reaching due to concerns about resistance, probably. Whether that's resistance to herbicides or pesticides, I would have thought. Also, there's obviously some ethical questions about the use of GMO cotton in certain countries. And there's also moves in certain West African countries, I think, actually, from stopping the use of some types of GMO cotton in those regions. So there's a bit of political activity surrounding that too. I'm not sure about the pricing situation, but I'm sure that's something to do with it too.
Understood. All right, Timo, back to the technicalities of the testing method. You mentioned that there is a limit of 0.01%. What is the 0.01% of what exactly is that limitation based on?
Yeah, that's a very good question. So that 0.5% comes from the molecular biology RT-PCR kit we are using, or the ingredients we are using. So the manufacturer of these says that if we are looking for a specific marker gene and we have like, let's say 100 milligrams of DNA, which is a fiction now, but we have 100 milligrams of DNA. We need to have at least 0.1 milligrams of GMO DNA to detect it. So it's difficult to calculate that into the real amount, but it's 0.1% of whole DNA should be then GMO DNA.
Understood. On the DNA extraction that you perform when you're preparing your test samples, and I guess this is also a marker as well, is there any way to identify the kind of cotton that it is and whether or not it's Egyptian or Pima cotton? Is there any way to do that in the work that you're doing in the lab?
No, not with that standard test. So I got this question several times now, so it's really worth thinking about it. So there are other test methods which might help us to get this kind of a result, but the question is not so easy. So on the one hand, if we have really different breeds, for example, we could do something like DNA fingerprinting, which has nothing to do with the test I just presented and has nothing to do with the OEKO-TEX thing. But in general, we in our molecular biology lab, we are able to do DNA fingerprinting. So if we have really two different cotton breeds, so different races of cotton, we could do fingerprinting and really differentiate them. But for example, telling where this cotton plant was grown, it goes much more into chemical analysis like isotope analysis and so on. So brief answer, in general, it's possible, but it's much more of an effort to do that, and we do not offer that as a standard test.
Understood. All right, can you briefly review again? I think there's some more interest in understanding thoroughly the testing procedure and how you have controls in place so that you fully understand the result that you get when you do run the GMO testing. Can you run through that once again and sort of remind us of how you make sure that the test result you get is reliable?
Sure. So on the one hand, we need a negative control. So that means that we use, let's say, a water sample and let it run through it. So that shows us if all the ingredients we are using for the test, so all the chemicals, the buffers, and the enzymes, and so on, that they are not contaminated. If one of them would be contaminated with a little amount of marker gene DNA, we would get a positive result, although the sample itself does not contain GMO. So therefore, we need to ensure that if we put just water in it, we don't get a positive result. So this is the negative control. What we also need to know is that we were able to extract enough DNA. So just guess, if we would get a negative result, so no GMO signal, and we would not do that control, it could be that we didn't get enough DNA out of the sample. So what we need to ensure is, yes, we got enough DNA, and that we do that by testing on cotton plant DNA. So if we get a positive signal in this one, we see, yes, it worked. We got enough DNA out of it. So the GMO or non-GMO test is valid. So these are the two most important controls.
Excellent. And has this test been verified by any, in terms of a test standard and a test method? Has this method been verified to the point that you feel it's a very reliable approach to identifying GMO?
Yeah, so what we did, we took part in one international round robin, I think it was last year, where the samples have been known, and it was only 2 institutes worldwide which have been able to identify correctly all these samples in the round robin, and one of us was us. So yes, we validated the sample, the test on the one hand by this international round robin, and there will be another one, I think, throughout the next months. And second, we draw several hundred samples from the market and validated our test internally.
Okay. Now, I know you said that this test is offered in conjunction with the Standard 100 by OEKO-TEX certification. So is there an additional cost for those organic cotton products that are seeking that Standard 100 by OEKO-TEX certification in addition to the GMO test? Is there an additional cost to those people?
Additional to the GMO test fee? I
think the other way around. So. Yeah, is there a different, if they want the OEKO-TEX Standard 100 certification and they are trying to get that certification for organic cotton and this test is required, is there an additional expense for the GMO test?
Yes, yes, okay. It's 445 euros.
Okay, there you go. All right, and we have someone asking for a few more details about the international round robin. Is there any other level of detail that you can provide about that process that you went through?
I'm not pretty sure. So it was the GOTS organized round robin, and I already know that there will be probably a much bigger one organized throughout the next months, but I'm not pretty sure about the stage of this one.
Okay. All right, wonderful. All right, John, I wondered if you had any closing comments before we concluded today's program.
Yeah, I just wondered about the sample sizes, Timo, that you mentioned there, saying that 8 to 10% of samples where you couldn't identify GMOs. What sort of sample numbers are we talking about?
So in that validation where we got this number out, we took 250 different textiles from out there. So all of these were final products. So shirts, socks, linen, and so on.
Okay. So they were fine. They were actually garments, not just the yarn or anything further down there.
Yeah, it was completely processed. So it was ready to use clothes and beddings and so on.
Okay. Well, thanks very much for that. I'm not sure if there's any more questions, Trish.
I think we've worked through them all, but so I appreciate both of you giving your time today to discuss this important information. And for everyone who's on the webinar, we will be sending out a link to today's recording. And if you did ask questions that were not answered, we will get back to you offline with the information that you're looking for. And feel free to reach out to Dr. Hammer or to me to get some additional questions if you have them at the conclusion of the webinar. And please look for that email link in the next several days. Thank you very much and have a great day.
Thank you. Bye-bye.
Bye.